In this video, I'm going to show you step by step how I made this neon LED sign. This technique can be used to create a sign of any shape. You just need a big enough 3D printer to print the frame for the LED strip. If you've ever seen EL wire, this is basically the bigger, better LED strip form of it. You can find this stuff online for like $25 for a 5-meter strip. Most of the strips take 12 volts, but you can find some that you can power with 5 volts. I saw some people online making some signs with these strips using laser cut acrylic frames to hold them in place, but I don't have a laser cutter. So I wanted to come up with a way to easily create these frames using 3D printing. These are the first two prototype signs I ever made with this technique. You can see it's literally just a 3D printed frame and the LED strip wired together. These first prototypes were very functional, but the wiring was pretty messy, so in my final designs I neatened the wiring up and also added a nicer power input. Here's what the signs look like powered up. I was very surprised with how bright this LED strip is. The Bitcoin sign here draws about 1 amp at 12 volts, so that's about 12 watts of LED power. That would be equivalent to like a 60 watt incandescent bulb, but it's not quite as bright as that because of the rubber coating surrounding the LED strip that blocks some of the light. Taking a look at the inside of these LED strips, the ones that I got are segmented every 3 LEDs, and you can see that there is 2 copper pads in between every set of 3, and that's where you are supposed to cut the strip and solder it. There's a black line on the back of the LED strip at each of these copper pads, and you can see that black line through a little slot in the rubber coating. So once you have your LED strip, the next step is to create a frame that will hold that LED strip in the shape that you want for your sign. Here's the 3D model that I made in Fusion 360 for the neon LED sign. It's just a frame with tracks for all the LED strip, and there's holes so that I can pull wires through and hide them in the back, and also a little hole that you can hang it on. I started by importing an image of the Ethereum logo. To scale the image correctly, I first made a line dimensioned to how tall I want the sign to be, and then when I imported the image, I just lined up the ends of the line to the top and bottom of the logo. Then in the next sketch, if you look at just the dotted lines, all I did was trace the lines that I wanted the LED strip to be in. So just the edges of the logo. Then I offset each of those construction lines by 2.6 millimeters, giving me a 5.2 millimeter wide channel here. Then I extruded the sketch 5 millimeters. This will form the base of the frame, and it allows me to easily create the walls by creating a sketch on the bottom and then projecting the faces of these channels, offsetting them by 4 millimeters on each side. And then I can extrude this offset area to create the walls. I extruded it up 15 millimeters. So that made the walls 10 millimeters because the base of it was already 5 millimeters. The next thing I did was fill in the little gap in between the two halves here. All I did was make a rectangle and extrude it up like 12 millimeters. Then I added fillets to all of the corners to make it look a lot nicer and also make it easier to bend the LED strip around the channels. Then I created the holes for the wires to pass through to the back side. These were positioned in a way that allowed me to connect them easily and create these channels on the back side as well. That would allow me to basically glue the wires in so that the back can be flush. And to make these channels, I literally just made a bunch of tangent lines between all of the holes. I only ended up using the ones down the center, but I added the other ones just because I could. And then I had my 3D model. Now you could follow this same process for pretty much any shape. All you would really want to do is just choose a different image, trace out the parts that you want to be illuminated, and then just make the walls like I did, and make some considerations for the wiring if you're going to have to connect multiple segments together like I had to. Ideally, you could design a sign that only needs one segment of LED strip, and you could avoid a lot of the wiring that I had to do for this sign because there was 4 separate LED strips. Then this was ready to 3D print, so I export the mesh to an STL and import it into Cura for slicing. I have my Cura set up for my Creality CR10 3D printer. The build plate is 300 millimeters by 300 millimeters, and the sign just barely exceeds that if you just lay it straight. If you tilt the sign, fits with plenty of room to spare, and I printed it with pretty standard settings, 0.3 millimeter layer height because it's pretty big and I didn't want it to take forever, and 3 top and bottom layers, 20% infill, 50 millimeter per second print speed, and then I also had to add supports for the wire channels on the bottom. Then it was ready to be sent to the printer and printed. Sorry I don't have a satisfying time lapse of the print, but the first thing that I did was cut the LED strip to the lengths that I would need and test fit them into the frame. To power this sign, I decided to use a female to male barrel jack wire with an inline switch. I cut off the male end and connected that to the first segment of the LED strip at the bottom of the sign, and that leaves the female end open so you can plug in a 12-volt wall wart power adapter. After you cut these strips to the size that you want, you have to expose the copper pads by cutting off some of the rubber coating. To do this, I used an X-Acto knife and just cut it completely off. I have heard of some people cutting like a flap that they could fold up and then solder and then fold it back down so you can do like a seamless solder, but I didn't bother with that. The first thing that I decided to solder was the power switch wire to the bottom segment of the LED strip. I had to drill a hole in the bottom of the frame because I forgot to model that in Fusion 360. Then I prepared the wires to be soldered by stripping only a little bit of the insulation off. When you're trying to solder to these tiny pads on the LED strips, it really can help avoid short circuits if you only strip about 2 millimeters of insulation off. I did one last test fit to make sure that I had the right size LED strip for this segment before I soldered the wires to one end of the segment. I'm doing this soldering work on a metal plate that you can attach these magnetic alligator clip arms to hold the wires in place, which was super handy for a soldering job like this. I tested the connection by flicking the switch a few times and it was good, so then I added some rubberized super glue to try and strengthen the connection and make sure that if the switch gets pulled on a little bit, the wires don't come flying out. So that's the first segment completed. If your sign only has one segment, this is all the wiring that you would need to do, but I have 3 more segments to connect. These LED strips are basically just 2 copper wires running through the entire strip, so you can connect them end to end or connect multiple to the same point. as long as the polarity is correct. For these, the positive side is the top and the negative side is the bottom of the strip. To connect these strips, I used 20 gauge stranded copper wire. For the first two strips, I connected them end to end. So on the first strip, I stripped back the plastic on the end to reveal the copper pads, and then I soldered a wire to each pad. Then I threaded those wires through the hole at the end of the first strip and cut them to the length that I thought I would need to connect them to the second strip, and then I stripped the wires and soldered them to the start of the second strip. To keep the wires neat here, I didn't give myself much slack. It was a pretty tight soldering job, but I was able to securely connect the wires to the strip. I added some super glue, and then the second strip was connected. I tested it to make sure that it would light up, and it did. So now all that was left to do was to connect those two side strips. To connect the two side strips, first I soldered two wires to one end of each of the smaller strip, and then I connected the positive and negative of both of the strips to the end of the second large strip through the holes at the top of the sign. On one of the side strips, I used an extra long wire so that I could connect the other side strip wire to that wire and then run it up to the top of the sign where I could connect it to the last strip. Then the sign was functionally complete. I added some epoxy to the wires on the back to hold them down into the slots, and I also added some rubber feet to the back so that it rests easily against the wall with a little bit of space for the wires. And that marks the end of this video. If you made it this far, that was pretty surprising, honestly, so thank you for that. Hopefully you learned something. If you do end up making something or have any suggestions, please leave a comment, and farewell.